Hello guys, welcome back to your physics class. Today's lesson, we're going to explain light and reflection in chapter 5. So in this chapter, we have three sections. Section 1 about the characteristics of light, such as electromagnetic wave. And section 2, we have many different topics about the flat mirror, reflection of light, flat mirrors, mirrors at an angle, relationship between motion of the object and the motion of its image in the flat mirror. Section 3 about the spherical mirrors, the two different types of spherical mirror, concave spherical mirror and convex spherical mirror, and also we will study the parabolic mirrors and the spherical aberration. Let's get started with the section 1, the characteristics of light, electromagnetic waves. Listen carefully. What is electromagnetic wave? The definition of electromagnetic wave, a wave that consists of what? That consists of oscillating or vibrating. Vibrating what? Electric and magnetic fields. So this is very important. Electromagnetic wave, a wave that consists of what? Oscillating or vibrating. Oscillating between what? Between two fields, electric field and magnetic field. So these two fields must be perpendicular. Okay, so these two fields are perpendicular to each other when they emit from the source. Which radiate out or from the source at a speed of light. All types of electromagnetic wave, they have the same speed at a given medium, such as and is equal to the speed of light. What does the speed of electromagnetic wave depend on? The speed of electromagnetic wave depend on what? It depends on the characteristics of the medium. For example, in a vacuum, the speed of the wave is faster than the other medium. Okay, for example, light wave is an example of electromagnetic wave. The speed of the light has maximum value in the vacuum comparing with the given medium. Like for example, the speed of light is higher than the speed of light in water. More density has more index of refraction but low speed of light. But low density has more speed and high speed. Electromagnetic wave travel in the speed of light, which is equal to 3 times 10 to the power 8. But in other medium, the speed of light is less. So C is the symbol of speed of light. Guys, C is the symbol of speed of light, always bigger than V. What is C? What is V? C, speed of light in vacuum. Okay? Speed of light in vacuum, but V, speed of light or wave, it doesn't matter. Okay, the speed of wave or light in medium, such as air, gas, solids. Okay, so this is the difference between C and V. Sorry. Okay, guys. This is one the image of the figure of electromagnetic wave oscillating between magnetic field and electric field. Electromagnetic wave is vary depending on frequency and wavelength. We have 7 different types of electromagnetic wave, but each of the electromagnetic wave has its own frequency and wavelength. Okay, so no one has the same wavelength and frequency. Each of them has its own frequency and wavelength, but all they have the same speed at a given medium. In the classical electromagnetic wave theory, light is considered to be what? A wave, because in modern physics, the light considered to be a particle. Okay, but in classical physics, the light considered to be a wave. Okay, but light behaves both wave and particle. Okay, so the interference of the light wave is the evidence of the light wave, and the photoelectric effect is the evidence of the particle of the light. Okay. And the wave are composed of the oscillating electric and magnetic fields. These fields are perpendicular to the direction in which the wave moves. Okay, the angle between electric field and magnetic field is 90, perpendicular to each other. Electromagnetic waves are transverse wave because we have 2 different types of wave: transverse wave and longitudinal wave. The type of electromagnetic wave is transverse wave. Why? Because it has up and down, it has crease and trough, not compression and rarefaction. Because longitudinal wave, the wave must be mechanical wave, but electromagnetic wave always transverse wave. The electric and magnetic fields are also at right angle to each other, which means perpendicular. Electromagnetic waves are distinguished by what? Difference in what? Frequencies and wavelength. So what is the difference between microwave and X-ray? They are different in what? In frequency and wavelength. The frequency of X-ray is not equal to frequency of the microwave or radio wave. Okay, they have different frequency and different wavelength, but they have the same speed at a given medium. In visible light, these differences in frequency and wavelength account for what? Different colors. Why the colors, like for example, what is the difference between red and blue? Two different colors. They are different because they are different in frequency. Okay? The frequency of the red color is not equal to the frequency of the blue color or other colors. So the difference in frequencies and wavelength also distinguishes the visible light from invisible electromagnetic radiation such as X-ray. So the types of the electromagnetic waves, types of electromagnetic waves or spectrum. How many types do we have? 7. We have 7 different types of electromagnetic waves. So you have to memorize in order, guys. Be careful. So you have to count one by one in order, okay, not randomly. The first one, what is the first electromagnetic wave? Radio wave. The second one, microwave. The third one, infrared wave. The fourth one, visible light. Why it's called visible? Because the others are not visible. Which type of electromagnetic wave are visible part? Only light. Only the light is visible. The others not visible. So we cannot see the radio wave, microwave, infrared. Okay? Only the visible light can be seen, such as the rainbow or the colors and the spectrums. Number 5, ultraviolet. Number 6, X-ray. The last one, what is the last type of electromagnetic wave? The last one is gamma ray. So we have 7 different types of electromagnetic wave. So the visible light, so we can analyze the visible light into 7 colors. Okay? So we can analyze the visible light or disperse the visible light into 7 colors. 1, 2, 3, 4, 5, 6, 7 colors. Started from what? From red. ROY-GB. RO. Sorry. It should be orange. O. ROY. After that, after O, Y. ROY. G. Green. B. Blue. I assume that this is indigo, but actually this is not indigo. I can't find indigo color here. So I'm very bad with the color. I can't recognize all the colors. So the last one is violet. ROY-GB, guys. So you have to write down in order also. Okay, you cannot write randomly. What is the first color? Red, which has the longest wavelength. After red, orange. After orange, yellow. What color comes after yellow? Green. After green, blue. Indigo, violet. Red color, orange, yellow, green, blue, indigo, between violet and blue, and the last one is violet. Okay, so we have 7 colors of the visible light. So we can see these 7 colors. So that is why we call this type of electromagnetic wave visible light. Why we call visible light? Because we can see it. The others cannot be seen. Guys, the first type radio wave, the radio wave has longest wavelength. Which type of electromagnetic spectrum or electromagnetic waves has longest wavelength? Radio wave. Which has lowest frequency? Longest wavelength but lowest frequency. As we are moving downward from radio to gamma ray, what happened to the frequency? Frequency gets more, increases. Okay, but from gamma ray to radio wave, frequency decreases. Wavelength is completely reverse of the frequency, inversely proportional to each other. For the gamma ray, because radio wave has longest wavelength, gamma ray should have shortest wavelength because they are different, inversely related to each other. Shortest wavelength. Which type of electromagnetic spectrum has the shortest wavelength? Gamma ray. But highest frequency, highest what? Frequency. Which type of electromagnetic spectrum has highest frequency? Gamma ray. Okay, so this is about the electromagnetic waves and electromagnetic spectrum. We have 7 types of electromagnetic wave, and the visible light also can be resolved into 7 colors, which can be seen by the human eyes. Periodic motion. But before talking about the periodic motion and describing periodic motion, I would like to tell you what is the wave. And in wave we have creased, wavelength, frequency. What is frequency? This is radio wave. Assume that this is radio wave. Guys, look. This is wave. This type of wave is transverse wave. We have what? We have crest. Okay? The top point is called what? Crest. And the bottom is called what? Trough. Okay? This is also trough. The distance between two crests is called what? Wavelength. It's called what? Wavelength. So the distance between two adjacent crests respectively is equal to what? Wavelength. What is wavelength? Is the distance between what? Between 2 points, such as 2 crests or 2 troughs. Also for the trough, the same thing is. And the distance from the equilibrium position to the maximum point is called what? This is amplitude. Okay? From equilibrium point to the highest point, from the equilibrium line to the highest point or to the lowest point is called what? Amplitude. This is amplitude. Okay? Guys, for the radio wave is a type of electromagnetic wave which has longest wavelength. Longest wavelength. It means that more separation between crests. Longest wavelength. But a few vibrations. Less frequency. More wavelength. But less frequency. What I mean by frequency is the number of up and down of the wave occurs in one period, in 1 second. Okay? What is frequency? Is the number of oscillation period of time. Number of oscillation, it means that number of up and down. We have up, down, up. Okay? 3 up and downs here. So this type of wave is a radio wave. But longest wavelength, but lowest frequency. But if you draw for the gamma ray, we have many vibrations, period of time in 1 second. Okay? So the wavelength is too less. Okay? This is the shortest wavelength. The distance between two crests is too short. So that is why gamma ray, this is gamma ray. That's why gamma ray has the shortest wavelength, but highest frequency. Why it has highest frequency? Because it has more vibration period of time. Like for example, in 1 second, time here is 1. In 1 second, how many up and downs we have? We have many up and downs. But here in 1 second, we have only 3 or 2 up and downs. So that is why radio wave has lowest frequency and gamma ray has highest frequency, highest number of vibrations. So periodic motion, each wave that propagates in a given medium is a periodic motion that repeats itself after equal intervals of time. Okay, for many vibrations we have a periodic motion. What is period? Is the duration or time of one complete cycle. It's time for what? One complete cycle. This is period. What is period? Is the time takes for one complete cycle. What is one complete cycle? In one complete cycle, we have one up and down. This is one complete cycle. What is this? This is one complete cycle. How about two complete cycle? Two complete cycle, it means that we have two creased and two troughs. Two creased, two troughs. This is how many cycles? Two cycles. If the time it takes until here, this time is not period. Like for example, if the time takes for this two wavelength is equal to 8 seconds, what is the period for this wave? Can we say this is period? No, this is not period. Period occurs only for one complete cycle. Okay, how many cycles do we have here? We have two cycles. If two cycles is equal to 8 seconds, one cycle is equal to what? 4 seconds. Now, this 4 seconds is what? Is a period. Okay, what is period? Period is a time takes for one complete cycle. So what is the difference between T capital and T small? T capital is period. Is what? Period. For what? For one complete cycle. Only for what? For one complete cycle. But delta T is time interval. What is this? Time interval. For many cycles. So this is the difference between period and time interval. Frequency of the wave is the number of oscillation of the wave covers in 1 second. Okay. Wavelength is the distance between two corresponding points, such as two creases, two troughs, as you can see here. Okay. And also there is a relation between frequency and period. Frequency is equal to what? 1 period. Okay. Period is equal to what? Reciprocal of frequency is equal to 1 over air. When period is given, you can determine frequency easily by using this equation. Whenever frequency is given, also you can determine period. For example, for 20 hertz, for 20 hertz frequency, what is the period? What is the known period? Period is equal to what? 1 over air. 1 over what? 1 over 20 is equal to what? 0.05 seconds. Okay, 0.05 seconds. Light is described as a particles or waves. Okay, we studied. The definition of light is a form of electromagnetic radiation that's visible to the human eye. We can see, because we can see the colors. It's type of energy that travels in a wave through the space. These waves are composed of what? Electric and magnetic field, because it is electromagnetic wave. Why are electromagnetic waves not similar to each other? Because they are different in frequency and wavelength. Because electromagnetic waves have different what? Frequencies and wavelength. Which one has the longest, highest frequency? Gamma ray. Lowest frequency? Radio wave. Longest wavelength? Radio wave. Shortest wavelength? Gamma ray. Why is electromagnetic wave transverse wave? Because electromagnetic wave composed of what? Oscillating electric and magnetic field that's perpendicular to each other. It has up and down. And has no particle. They can pass through the vacuum even. Which of electromagnetic wave has highest frequency? Highest frequency, gamma ray. Which of electromagnetic spectrum has lowest frequency? Lowest frequency, radio wave. Longest wavelength, radio wave. Shortest wavelength, gamma ray. Speed of electromagnetic wave. So we have an equation to determine frequency and wavelength. C is equal to what? Frequency times wavelength. This is the equation of electromagnetic wave. What is this? Equation of electromagnetic wave. What is C? Speed of wave, of electromagnetic wave. Speed of what? Electromagnetic wave. Which is equal to 3 times 10 to the power 8 meter per second. So you have to memorize this value of speed of light in vacuum. F frequency. What is this? This is frequency measured in what? Hertz. Lambda, this is wavelength. The symbol of wavelength is lambda. Measured in what? In meter. Okay? So this equation is very important, and also you can rearrange this equation. C, frequency, wavelength. C is equal to what? Frequency times wavelength. Frequency is equal, this is division. Frequency is equal to what? Speed of light divided by wavelength. Frequency is equal to what? C over wavelength. Wavelength is equal to what? C over frequency. It's very easy. Okay? So we have three equations. Frequency, speed over wavelength, wavelength, speed of wave over frequency. So the relation, because C is constant, guys, look. Because C is constant, what is the relation between frequency and wavelength? Inversely related. What do you mean by inversely related? Like, for example, if the wave has longest wavelength, which means has lowest frequency. More wavelength has less frequency. But less wavelength has more frequency. Frequency and wavelength inversely proportional. But before solving the question, guys, you have to keep in your mind, whenever this frequency is given in megahertz, you have to convert to what? Hertz. It's not allowed solving question with megahertz because this AM is prefix. You have to convert to the pure unit. Megahertz to hertz, you have to multiply 10 to the power 6. Kilohertz to hertz, you have to multiply, you have to multiply 10 to the power 3. Okay? This is for frequency. But for wavelength, this is for frequency. But for wavelength, whenever the wavelength is given in nanometer, you have to convert to meter. How? Multiply 10 to the power negative 9. Micrometer, 2 meter, multiply 10 to the power negative 6. Okay? Centimeter, you have to convert to meter, multiply 10 to the power negative 2. But kilometer, convert to meter, multiply 10 to the power 3, positive 3. Okay? So this conversion is very important for solving question about for the electromagnetic waves. Sample problem 5A. The AM radio band extends from 5.4 times 10 to the power 5 hertz. This is F1, which is equal to 5.4 times 10 to the power 5 hertz. And F2, 1.7 times 10 to the power 6 hertz. What are the longest and the shortest wavelength? Lambda 1 is equal to what? Lambda 2 is equal to what? So before solving question, you have to know which one longest wavelength, which frequency has longest wavelength, and which frequency has shortest wavelength. So compare these two frequencies. Which one is bigger? Absolutely F2 is bigger because it's power 6, not 5. So because F2 is bigger than F1, which wavelength is longest? So lambda 2 less than lambda 1. Lambda 1 must be bigger than, lambda 1 has longest wavelength. This one has longest. Why? Because F2 bigger than F1. If F2 bigger than F1, lambda 2 less than lambda 1 because they are inversely related. Okay? They are inversely related, but C is constant. C1 is equal to C2. And also you can solve this question very easy. At first you have to write down the equation for each of them. Lambda 1 is equal to C over 1. Okay? C is constant, 3 times 10 to the power 8. F1 was given 5.4 times 10 to the power 5. Okay, lambda 1 is equal to 560 meter, or 5.6 times 10 to the power 2. Lambda 2 is equal to C over F2, 3 times 10 to the power 8, 5.4, sorry. The second wavelength, okay, the second wavelength is equal to what? 1.7 times 10 to the power 6, which is equal to 1.8 or 180 meter. So which one is bigger? Lambda 1 is bigger than lambda 2. Look, before solving question, I said lambda 1 must be bigger than lambda 2. Okay? Practice 5a, question 1. Practice 5a, question 1. The question says, gamma ray bursters are objects in the universe that emit pulses of gamma rays with high energies. This frequency of the most energetic bursts has been measured at around 3 times 10 to the power 21 hertz. What is this? This is frequency. How do you know this is frequency? Because of the unit. F is equal to what? 3 times 10 to the power 21 hertz. What is the wavelength of the gamma ray? What is what wavelength? Guys, wavelength is equal to what? C over F. C constant. Frequency given 3 times 10 to the power 21. 3 with 3, 1 times 21 minus 8, 10 to the power negative 13 meter. This is the wavelength for this gamma ray, which is the shortest wavelength. Okay? Look, question 1. 1 times 10 to the power negative 13 meter. Question 2. What is the wavelength range of FM radio? Question 2. How many frequencies do we have? 2. This is F1 and this is F2. Guys, F1 is equal to what? 88 megahertz. F2 is equal to what? 108 megahertz. Convert to hertz. Don't forget this convert, please. How megahertz to hertz? 10 to the power 6. 10 to the power 6. Now, F1 is equal to what? 88 times 10 to the power 6 hertz. F2 is equal to 108 times 10 to the power 6 hertz. Guys, which one is bigger? Absolutely F2. F2 bigger than F1, so that is why lambda 2 should be less than lambda 1, because they are inversely related. Okay? Lambda 1 is equal to what? C over F1. 3 times 10 to the power 8 over 88 times 10 to the power 6, which is equal to, question 2, 3.4 meter. This is equal to 3.4 meter. This is lambda 1. For lambda 2, C over F2, C 3 times 10 to the power 8, F2 108 times 10 to the power 6, which is equal to what? It should be less than 2.78. 2.78. This is lambda 1 and lambda 2. Which one is bigger? Lambda 1 is bigger than lambda 2. Lambda 1 bigger than lambda 2. This is question 2. Question 3, shortwave radio is broadcast between 3, exactly the same question as we solved it here. Question 2. This is F1, this is F2, convert megahertz to hertz, multiply 10 to the power 6. What do you suppose the part of the square? So we have to find the range of the wavelength. Lambda 1 is equal to C over F1, 3 times 10 to the power 8 over 3.5 times 10 to the power 6, which is equal to, question 3, 85.7. This is first wavelength, and the second one, C over F2, which is equal to 3 times 10 to the power 8 over 29.7 times 10 to the power 6, 10.1 meter. The wavelengths are short than this of the AM radio band. It's very easy. Question 4, what is the frequency of an what is unknown? Frequency is unknown. Frequency in question 4 is unknown. Frequency is unknown. It has wavelength 1 kilometer. Guys, pay close attention for the unit of wavelength, 1 kilometer. Wavelength is given in what? Kilometer. You have to convert to meter. Multiply 10 to the power 3. Now, wavelength is equal to what? 1 times 10 power 3 is equal to 1,000 meter. So, frequency is equal to what? Speed of light divided by wavelength. 3 times 10 to the power 8 over 1000. Question 4 is equal to 3 times 10 to the power 5 hertz. This is frequency of this wavelength. Question number 5. A portion of the visible spectrum that appears brightest to the human eye is around 560 nanometer. Question 5. Wavelength. This is what is this? This is wavelength. Wavelength is equal to what? 560 nanometer. Convert to what? To meter. Multiply by what? 10 to the power negative 9 is equal to 560 times 10 to the power negative 9 meter. Okay? As I told you, not allow solving question with the prefix such as nano or something like this. You have to convert to the SI unit, which corresponds to yellow. This wavelength is yellow. Okay? What is the frequency of this wavelength? What is unknown? Frequency is unknown. After converting the wavelength, now we can solve the question. C over wavelength, 3 times 10 to the power 8 over 560 times 10 to the power negative 9. Question 5 is equal to 5.4 times 10 to the power 14 hertz. This is the frequency for this wave, or for the yellow and green. Okay, the yellow wavelength. The last question: what is frequency? Frequency is unknown of the lightly energetic ultraviolet radiation. This is ultraviolet, which is wavelength is equal to 125 nanometer. Convert to meter. Multiply 10 to the power negative 9. Frequency is equal to what? This is nanometer, not kilometer. Frequency is equal to C over wavelength, 3 times 10 to the power 8 over 125 times 10 to the power negative 9. Frequency for this ultraviolet radiation is equal to 2.4 times 10 to the power 15 hertz. Okay? So that's all about the electromagnetic spectrum and electromagnetic waves. Another topic, guys, waves can be approximated as rays. Okay? Light in physics is a form of electromagnetic radiation that can be detected by the human eye, visible part. It's a type of energy that travels in a wave through the space. A ray of light is a straight line that represents the direction in which the light travels. Okay? What do you mean by this straight line? It indicates the direction of the light wave. What is this? The direction of what? Of light wave. But actually the light spreads in the shape of the spherical wave front. Okay? Not a straight line, but this straight line indicates the direction of the light. Okay? What is the Huygens principle? This principle is very important. Huygens principle, all the points on the wavefront of the plane wave can be treated as a point sources. This is very important, guys. Once again, listen carefully. The definition of Huygens principle: all the points on the wavefront of a plane wave can be treated as a point source. Now, let's draw a point source of light. Assume that this is light. This is wavefront, guys. What is this curved line? This is wavefront. Okay? Each point, all the points on the wavefront, so all the points on the wavefront, or each point on the wavefront can be treated as a point source. Okay? That's coming from a source. Like, for example, if we have a source of light, and if we have a barrier here, assume that this is a barrier, okay? And let's make some small holes in this barrier. Okay, some small holes in this barrier. Now, how many holes do we have? 1, 2, 3, 4, 5. 5 holes. Guys, whenever the wavefront hits the wall, the barrier, the light comes out from this small hole like this. From each source, the light comes out or emits from the hole like this. Okay? Now, at first, how many sources did we have? 1. But each point of the wavefront, when passed through the slits and the hole, they act as a point source. Okay, now assume that we have, how many sources do we have? 1, 2, 3, 4, 5. Okay, how many sources do we have now? 5 sources. But actually, we had only one source. But each point on the wavefront acts as a wave source when passed through the slits. Okay, this is the Huygens principle. According to the Huygens principle, a wavefront can be divided into point sources. Divided into what point source? The line tangent of the wave leads from this source marks the wavefront new position. What is the useful of Huygens principle? Huygens principle can be used to derive the properties of any wave, including light that interacts with the matter. Illuminance decreases as the square distance from the source. Now we have another topic about the illuminance and luminance. You have probably noticed that it's easier to read a book. It's easier to what? Read a book beside a lamp using 100-watt bulb rather than 25-watt. So which one has more intensity of light? 100-watt power is equal to 100-watt, or 25 watts, or 25 watts. So which one is easier to read a book, beside 100-watt or 25-watt? Absolutely, this one has more intensity, has more luminous or illuminance, or has more intensity. So it's easier to read a book beside 100 watts of power of the lamp rather than 25 watts. So in this case, intensity of the light directly proportional to the power. More power provide more intensity and more luminance. And it's also easier to read near the lamp than further from the lamp. So which one easier to read book? Near the lamp or further from the lamp? Absolutely near the lamp. Near the lamp is easier to read a book. Okay, why? Because intensity with the distance from the source inversely related. Okay, further apart from the source, less intensity, less luminance. What does the intensity of light depend on? This is very important, guys, be careful. The intensity of the light depends on 2 factors. The first one, the amount of energy emitted from the source, which is power. Okay, the first one is what? The amount of energy emitted from the source, like energy per unit of time, power. The second one, the distance from the light source, inversely. With the power and energy rate is directly proportional, but with the distance is inversely related. What is luminous focus and illuminance? Luminous focus, the rate at which the light is emitted from the source is called luminous focus and is measured in lumens. What is luminous focus? The rate at which the light is emitted from what? From source. It's called the luminous flux. The amount of the light that emits from the source is called the luminous flux. But illuminance, what is illuminance? Luminous flux is divided by area. Illuminance, guys, look, is equal to what? Luminous divide by what? By area. The area of the propagation of the light, as you know, the light propagates in a spherical shape, okay? So the area of the sphere is equal to 4 pi r square. So illuminance is equal to what? Luminance divide by what? 4 pi r square. So illuminance inversely proportional to the square. Inversely proportional to the area. More area, less illuminance and less intensity, because the same amount of energy spread over the large and wide area. Why the intensity of the light decreases as we move further from the source? Because the intensity of the light is inversely proportional to the square of the distance. Inversely proportional to what? The square distance of the source, from the source. And due to the spreading of the light waves over a large area, in other words, if you double the distance from the light source, if you double the distance, illuminance decreases by factor 1/4. Okay, decreases to 1/4. If we double distance, what happened to the intensity of the light? Decreases by 1/4. Luminance flux, less light falls on each unit square of, as the distance from the source increases. This is luminance and this is illuminance. Okay. As we move further from the source, what happened to the intensity? The intensity of the light decreases. Whenever the distance increases, the intensity of the light decreases. Okay. We finished this section, guys. Look, section review 5.1. Identify which portion of the electromagnetic spectrum is image of the following. Microwave is a microwave also. Television set, radio wave, visible light. Single lens of reflex camera, visible light. Question 2, it's very easy. We have frequency, we have to find wavelength. It's very easy, okay? And question 3, Galileo performed an experiment to measure the speed of light by timing how long it took the light travel from lamp. He was holding to an assistant about 1.5 kilometers away and back again. Why was Galileo unable to conclude that the light had a finite speed? Because the speed of the light is too great to be measured over such a short distance. Okay, it requires more distance to measure the speed of the light. So the time interval for the light in Galileo's experiment is about 1 times 10 to the power -5. So that's why he couldn't conclude at first. Question 4, how bright would the sun appear to an observer on Earth if the sun were what? 4 times further. 4 times further, it means that the distance increases by 4. So express your answer to the fraction of the sun's brightness on the Earth. So illuminance becomes what, guys? Look. Is equal to 1/4 square, or intensity. 1/4 square. Guys, look. Intensity is inversely proportional to the square distance. The distance of the sun, assume that we're 4 times further, 4 square. It's gonna be what? 4 square. Intensity decreases by what factor? 1/16. 1/16 of the sun's brightness on the Earth's surface. Okay. Section 2 about the flat mirrors. Okay. In this section, guys, we will talk about the flat mirrors, but we have let me analyze the types of the mirrors. We have 2 different types of mirrors, flat mirrors and spherical mirror. So the spherical mirror can be classified into 2 main types, concave spherical mirror and convex spherical mirrors. A flat mirror, the reflection of light. Before talking about the flat mirror, let's talk about the reflection of light. What is reflection? The change in direction of an electromagnetic wave. What is reflection? The change in direction of what? Of an electromagnetic wave, such as a light wave. For example, if we have a mirror and this is incoming light, this is normal, and this is incoming light, and this is going to be reflected light. So what is this? This is reflected. Why the light is reflected? Because of this mirror changing direction. What is reflection? The change in direction of an electromagnetic wave at a surface that causes it moves away from the surface. For the first time for incoming light, the light moves toward the surface, such as mirror. But for the reflected ray, this is reflected ray. Reflected ray. Okay? Okay. So we have some keywords and some important notes about the reflection. light traveling through a uniform substance, whether it's air, water, or vacuum, the transparent medium, or a uniform substance. So the light travels in a straight line. Okay, when the light encounters a different substance, its path will change, like rough substance or smooth substance. All substances absorb at least some of incoming light and reflect the rest. So if the incoming light, if the power of the incoming light, for example, assume that 100 watts, the reflected ray, the reflected light is not equal to the same power, not 100 watts. Why? Because at least some of the emitting or incoming light absorbed by the surface. Okay, some of the energy absorbed, some of the light absorbed by the surface, and the other reflect. Okay, absorbed by what surface? All substance absorb at least some incoming light and reflect it. A good mirror, a perfect mirror, or a good mirror, a perfect reflector can reflect about 90%. So in this case, 90% of the light is reflected. So here we had 100%. What happened to the 10%? The 10% absorbed by what? Absorbed by surface. So it is varies. This absorption is varies. Okay, it depends on the type of the surface. For the smooth surface, such as flat mirror, a perfect reflector, 10% of the incoming light absorbed by the surface and 90% will be reflect. The texture of the surface and the reflection of the light, the manner in which the light is reflected from the surface depends on the surface smoothness. The difference between, we have two different types of the reflection. Reflection of light in a smooth surface and the reflection of light in a rough surface. We have two different types of surface: diffuse reflection, specular reflection. In diffuse reflection, it is a rough surface such as paper, clothes, or unpolished wood. But specular reflection, it's a smooth surface such as a mirror or water in a pond. The second one, light reflected in multiple different directions. Okay? But in specular reflection, the light reflects in a single direction. All of them, they have the same angle. Okay? In a diffuse reflection, the light reflected in a multiple direction, multiple angles, but specular, all they reflect with the same direction. The angle of reflected light is not equal to the angle of incidence light. So theta is not equal to theta prime. Theta angle of incoming, this is angle of reflected. But in specular reflection, theta is equal to theta prime. Now incoming and reflected angles are equals for the specular reflection. So in this chapter, in this book, we assume that all types, the types of the material is specular reflection. Okay, we have we solve and we talk about the specular, not diffuse reflection. Okay, all cases about the specular reflection. Incoming and reflected angles are equal. Angle of incidence, what is angle of incidence and angle of reflection? Assume that this is surface, this is mirror, and this is incidence light. Okay, what is this? This is incidence light. Incidence light or incoming light, it doesn't matter. Okay, incidence light or incoming light. And this is reflected light. So the point that when the light is a straight line drawn perpendicular to the surface at a point where the light strikes, so the light strikes at this point, and this point is called what? Normal. This point is called what? Normal. This is normal. Guys, look, the angle of incoming light or incidence light with the normal is called what? Theta. What is theta? Angle of incoming light. What is theta? Angle of incoming light. Angle of incidence or. What is theta? Angle of incidence. Is the angle between incoming light and normal. Okay? The definition of angle of incidence, the angle between ray that strikes the surface and the line perpendicular, which is normal to the surface at the point of contact. Okay, so you can define the angle of incidence in very simple term, and you can say is the angle between incoming light and the normal. What is angle of incidence? Is the angle between incidence light and the normal. Angle of reflection, theta prime. What is this? This is angle of reflection, theta prime. Theta prime, angle of reflection. Angle of what? Angle of reflection. Is the angle formed within light perpendicular, which is normal to the direction of the reflected rays. Theta and theta prime. Law of reflection. What is law of reflection? When light hits a smooth surface, such as mirror, at an angle, it bounces off at the same angle. Angle of incidence is equal to angle of reflected. Okay? For example, if this angle is 30, this angle also 30. What is this 30 degree? Is the angle between incoming light and normal. So what about the angle between incidence light and the surface? If this is 30, this angle should be 60. The summation for both of them must be 90. What is the difference between this 60 and this 30 angles? Degrees. For the 30 degrees, the angle between incidence and the normal. Incidence light and normal. But 60 degree is the angle between incidence light and the surface. This is surface. The mirror is the surface. If the angle between incoming light and normal is 40 degree, the angle of the incoming with respect to the surface, it becomes 50 degree. Angle between the incoming ray and the surface, 90 minus 30, and for the reflected with the surface, 90 minus theta prime. If light hits a mirror at a certain angle, it will reflect of the same angle. Theta is equal to theta prime in the flat mirror. The line standing straight out for the surface is called the normal, and the angle of the light makes when it hits the surface is equal to the angle it makes when reflected off. So, and flat mirror, that's all for today, guys. Inshallah, in the next lesson, we're going to talk about the flat mirror, and we will study the properties of the image that formed by the flat mirror. Thank you for listening.